In this video we'll begin our discussion of circuits, and we'll start with one of the very important set of definitions. There are two types of circuits from which all other more complicated circuits can be reduced. These are called parallel circuits and series circuits. It's important that you know the definition of these. There's not how they look on a drawing that determines their definition, but it is in fact the way the voltage and the charge, or equivalently current, is flowing through the circuit elements. An element could be a capacitor, a battery, it could be a resistor or inductor. We'll see lots of elements later on. These are things that can drop voltage across them. So in a circuit, if you want to have and say that something is parallel, the definition is this: two electrical circuit elements, for instance two capacitors, since that's all the elements we know about right now, are parallel if and only if they both have exactly the same electrical potential difference. Now let me discuss very quickly the difference between same and equivalent. Equivalent means you get the same numerical value, for instance 3 volts. That's not the same thing as having the exact same. Same means that when you measure the voltage across one element, you simultaneously have measured the exact same voltage across the other. They are the same voltage, the exact same measurement. Not that two measurements give the same number. That's equivalent. Okay? So this thing says that if you measure one element's voltage, you simultaneously measure the voltage element on another one if they are in parallel. Let me show you an example of this. If we place our voltmeter leads between points A and B on this circuit, this point here A and this point B, we simultaneously measure the drop of the voltage across capacitor 1. This is VAB. Let's now put the plus lead on this side and the minus lead of my voltmeter there. There's my voltmeter. Plus lead, minus lead, and connect it right there. Every point along here, since this is a wire, is an equipotential surface. In essence, it's a single point. Likewise, every point along this path is an equipotential surface since it's a conductor, so it's just one point. So it's as if I put my meter between here and here. The voltage across capacitor 1 is voltage VAB. Marking all of this point by a single thing, A, which is called a node, is very convenient because it enables us to quickly see when things are in parallel or series. So all these points here is point A, and all these points here is node B. Now, in the same way, if we think about it in terms of the other one, these points here are all a conductor, so they're all the same point. So all these red points are the same as those green points. They're simply point A. So connecting the voltmeter to this point here or here on the capacitor is the same. And likewise, all these points over here to this capacitor are the same point. So we see that when we connect to points A and B, we have measured the voltage across C2, which is the voltage VAB, and we have simultaneously measured the voltage across capacitor 1, which is VAB. If this is the case, the two elements are said to be in parallel. If that's said, they are in parallel. Now let me show you an example why you shouldn't pay attention to the way things look. The question says, in this drawing, are the 3 capacitors in parallel? That means that if I connect my voltmeter here between A and B, do I measure the voltage across all 3 capacitors simultaneously? Well, I could see that, again, all of these points are the same, and all of these points are the same. So this is voltage VAB. So that's the voltage across the top capacitor. Likewise, all these points are at point A, and all these points over here are point B. So in green, I see that the middle capacitor is also voltage VAB. But capacitor on the bottom is not VAB. The voltage across it is actually between point C and point B. So its voltage is VCB. So answer is no. You have to pick your fingers up from points A and B in order to measure across this capacitor. B finger can stay, but the A finger has to leave point A and move over to point C with your voltmeter to measure the voltage across the bottom capacitor. They are not in series. They are usually drawn actually this way. There's the two capacitors drawn from point A to this point B, and then point B is drawn to point C. And in that drawing, which is exactly the same as the drawing below, they don't look in parallel anymore. It is not the way they are drawn. It is the definition of simultaneously measuring the voltage across all three capacitors that's important. Okay? So it's important that you understand the definition of parallel. Also, notice the voltage across all of them are 3 volts. That doesn't matter. It's not that the number's the same. It's simultaneously measuring the voltage at the same time. That's important. So these capacitors, although they may all have 3 volts on them, are not in parallel. All right, see you in the next video.